All right, so for the last vocab word, angle trisectors, let's just jot down the definition. Okay, so two rays that divide an angle into congruent angles trisect the angle. Let's look at an example in both of these. Okay, if I have angle A, B, E, and I'm going to add in two rays, C and D. Okay, if we are given that angle ABC is congruent to angle CBD, which is also congruent to angle DBE, okay, then we could conclude that these rays are trisecting this angle. Excuse me, I'm sorry. Okay, so we could also put a single arc, and a single arc just to indicate that all of those angles are congruent. All right, let's look at one more example. Well, let me give you the picture first. Okay, so angle S, we have point T, point Y, and Vx. Okay, so if ray SV and ray SX are trisectors, of angle TSY, okay, so if these are trisectors of this angle TSY, we could conclude that this angle is congruent to that angle, which is congruent to that angle. Okay. So now let's go to some practice problems that work with all of this vocabulary that we just introduced, and let's see how we do. All right, practice question number 1. Okay, based on the diagram that we have right here, is S considered the midpoint of RT? So let's think about that for a second. Is S the midpoint of RT? Well, I know that this segment is congruent to this segment, okay, but I have an issue with this. I'm going to say that no, okay, this can't be the midpoint because the points are not collinear, which is needed to have a midpoint. Okay, let's take a look at the next one. Okay, if BD bisects angle ABC, okay, does ray DB also bisect angle ADC? Okay, so we're given that ray BD is bisecting this angle, so this angle is being cut in half, okay, or into two congruent pieces, but they're asking, does that imply that the opposite angle is being cut in half? And I'm going to say no, there's really not enough information to draw that conclusion. All right, let's take a look at the next example. If B and C trisect segment AD, so let's think about that. The segment is being trisected. So the segment is a piece that's being cut into 3 congruent pieces. So really, if I want to illustrate this first part, okay, I can add those tick marks. So if B and C trisect this segment, does ray AB and ray EC trisect the angle? And that's definitely going to be no. And this problem is really pointing out the difference between trisecting a segment versus trisecting an angle. Just because the segment was trisected does not mean the angle was trisected, and vice versa. Okay, so no, it's true that segment AB is congruent to segment BC, which is congruent to segment CD, but that is all we can conclude. Okay, let's take a look at 4. Okay, given that PS, ray PS bisects this angle, angle RPO, I could indicate that right here. Okay, we're going to prove that angle RPS is congruent to angle OPS. Well, that's what I just concluded. Let's think about what I was using to make that conclusion. Okay, I was using this vocabulary word right here. Okay, so I can state the following. Okay, given that PS bisects angle RPO, we can conclude that angle RPS is congruent to angle OPS, okay, by definition of angle bisector. Okay, so this is not a real formal proof. We were just trying to indicate what you can conclude when you are given that you have an angle bisector. Okay, then let's take a look at this one. Let's talk about what you can conclude when you have a segment bisector. Okay, so in this picture right here, they're saying that line CM bisects segment AB, right? So if I want to talk about what we can conclude the 2 congruent segments. So while this is not a formal 2-column proof, I want you guys to understand what conclusion we can make, okay, when we are given that we have a segment bisector. Okay, and last but not least, okay, if segment EH, and let me slide this over so you can see, is divided into a ratio of 5 parts to 3 parts to 2 parts from left to right, okay, and also if the entire length of segment EH is 30 units, we're going to find the length of FG and name the midpoint of segment EH. So let's talk about this right up here, okay. This is the ratio. Now these ratios are split into congruent pieces, or congruent parts. So 5 parts to 3 parts to 2 parts. These are all equal parts that we're talking about. So I can say this is 5 parts, and since I don't know what the parts are, we could call them X, to 3 parts, okay, to 2 parts. So the only thing I know about these parts is that all of them added up, 5X plus 3X plus 2X, okay, equals 30 units. So we could combine like terms, giving us that 10x equals 30. Okay, divide by 10 on both sides, so x equals 3. Okay, now I can use this information to answer the final question. What's the length of FG? Well, FG is 3x, so the length of FG would be 9 units. Okay, and we're going to name the midpoint of segment EH. Well, this is 5 parts, and this is 2 parts plus 3 parts, so 5 parts to 5 parts. It looks like F is the midpoint, okay, in this, and on for segment EH. Okay, so if you need to go back and rewatch any parts of this video, but if you are done taking notes, okay, your homework is the following questions, and we will talk about these on Tuesday. Thanks, guys.